This is video lesson number 3 to go with systems of linear equations, essential skill. Moving on to the elimination method for solving systems of equations. I'm just going to go ahead and follow the directions off to the side and work through a few examples. So we want to make sure that all of the like terms are stacked up. What I mean by that is you want all of the x's stacked on top of the x's, all of the y's on top of the y's. Likewise, all of the equal signs stacked on top of each other, and all of the constants. So constants are numbers that don't have a variable attached to them. So in this case, it looks like everybody is stacked up. Then the next thing that I want to do is I want to choose a variable that I'm going to eliminate. Okay. Ideally, I would like to add straight down and get somebody to disappear. Hopefully I don't have to do any multiplication to make that happen. So in our first example here, we don't have to do any multiplication. If I add straight down, I know that my x's are going to cancel each other. So I'm going to go ahead and just draw a line here, and I'm going to go ahead and put a little plus sign there, and I'm going to add straight down. My x's are going to disappear. If I add my y's, I'm going to get 5y, and then if I add my constants, it looks like I'm going to get 13. So when I go through and I solve this, I'm going to go ahead and divide by 5. Those are going to cancel, and it looks like I'm going to get y is equal to, well, 13 isn't perfectly divisible by 5, so I think I'm just going to leave it as 13 over 5. Now, don't worry, I know that the numbers look kind of nasty, but that's actually okay. So I'm going to take this answer and I'm going to choose one of the original equations to plug this into. It doesn't matter which one you choose. I think I'm going to go with the second one only because the numbers are smaller, although I do have negative signs in there, so I'm going to be aware of those guys. So I'm going to copy down the equation that I'm going to plug it into. And then I'm going to carefully plug in what I just found. So everywhere I see a y, I'm going to plug in my 13 over 5. And then continue writing my equation. Okay, most people, including myself, aren't big fans of having fractions in a problem while they're trying to solve. But that's okay, because what we can do is we can eliminate the fraction itself. So if everybody had a denominator, so I'm going to give everybody a denominator here. So if the x had a denominator, it would be a 1. If the 10 had a denominator, it would be a 1. All right. Now, if I looked to see, well, what would the common denominator be if I were to get them to match? And it would be a 5. So I'm going to use that 5 to eliminate all of the fractions. I'm going to take this entire equation, and I'm going to times it by 5 over 1. So I'm going to distribute this 5. So this 5 is going to get multiplied all the way out here. So that's going to give me a negative 5x over 1. Remember, when we multiply fractions, we go straight across. And then I'm going to take the 5 over here. And I'm going to do 13 times 5. And then I'll do 5 times 1 on the bottom. I'm not going to actually do the multiplication yet because I think I can make this a little bit easier on myself. Then I'm going to multiply it here. It does need to go all the way through the equation. Okay, now if I did this correctly, all of my denominators will disappear. So a denominator of 1, that's not necessary. A denominator of 1 is not necessary. It's that 5 that's the issue. But if you look here, I now have 5 over 5. And 5 divided by 5 is just 1, so it will cancel. Now, if I rewrite my resulting equation, I get negative 5x plus 13 is equal to negative 50. Now, I know that the numbers are bigger now, however, there's no fractions. So most people are a little bit happier at this point. So let's go ahead and subtract our 13 to the other side, so I don't have to worry about any fractions involved. Now, maybe I get a fraction answer, but that's okay. There's nothing wrong with that. And then that gives me negative 63. I'm going to divide by negative 5. Those are going to cancel, and then that's going to give me x is equal to positive 63 over 5. 5 doesn't go into 63 evenly, so I'm just going to leave it like that, which is totally fine with me. Don't forget to write your answer as a solution, which is as a point. So here, my x was 65 over 3, and my y, over 5, excuse me, and 13 over 5. So now we have our first solution. Not pretty, but we could still solve it, not a problem. All right, let's move on to the next one. So the next one we have down here at the bottom. I'm going to go through and do the exact same process. Now I want to pay attention to if everybody is stacked up or not. Well, in this case, it is. X's on top of X's, Y's on top of Y's, equals, and constants. Unfortunately, right now, if I add straight down, nobody disappears. My x's would add together to become a 2x, so that doesn't go away. My negative y and my 2y would add together to become a positive 1y. And then it doesn't matter if the numbers go away. I need the variables to go away. So I think I need to do a little bit of work here. So now I'm on step 3. Step 3 off to the side, I'm going to multiply as I need to. As at this point, I'm going to choose what I want to get rid of. It's up to you. You can either get rid of x's or y's. And I think I'm going to get rid of the x's because the numbers in front of the x's already match. They're already both 1s. I just need the signs to be different. So I'm going to choose one of the equations. It doesn't matter which one. And I'm going to multiply that equation all the way through by -1. I'm just trying to flip the sign on it. So I'm going to take the first equation and I'm going to multiply through by -1. And I'm just going to slide that equation over here. So that's going to give me a negative x plus y is equal to positive 5. Okay, now let's take the second equation and just kind of slide it over. I want these guys to still be stacked up on top of each other. Now if I add straight down, my x's will disappear. So if I do that, these guys go away. That gives me a 3y, and that gives me a 9. Oh, this one is much better. If I divide by 3, it looks like y is going to be equal to 3. Remember, you still need to find the x value. So go back to the original equations, choose the one that you prefer. I think I'm going to go ahead and use the first one. So I'll take this, and I'll take my first equation, which was x minus y is equal to -5. I'm going to plug in what I found. My y is 3. And then solve for x. So add 3 to both sides. It looks like I'm going to get x is equal to -2. Don't forget that you need to write your answer as a point. So my solution to the system, and remember it's x first, which is -2, and y second, which was positive 3. Okay, moving on, we have one more problem here that we need to do for this. And this one is a tiny bit more, excuse me, this one was on the next page. Let's go ahead and flip over. The last example here, this one's a tiny bit more complicated, not a huge amount. You'll notice that things are not stacked up. So they're close, though, very, very close. So I need my x's on top of each other, my y's on top of each other, equal signs on top of each other. But if you take a look at the second equation, I think all I really need to do here is just flip those two guys. So maybe I want the 2x to come first and then the -5y to come second. So I'm just going to go ahead and move this guy over. I'm going to put my 2x first. They're on the exact same side of the equation, so you don't have to like subtract to move it over. You can just kind of slide things around on the same side of the equal sign. -5y is equal to -19. Okay, now I'm going to go ahead and take my original first equation, slide that guy over, and hopefully everything is stacked up now. And then once it's stacked up, then I can look and see, okay, if I add straight down, can I get somebody to disappear? Unfortunately, no, I can't. If I add straight down, my x's turn into a 5x, well, that's not a 0, and my y's turn into a -1y, and that's not 0 either. So at this time, you need to decide what you want to match. Do you want to get the x's to match or the y's to match? Remember, you want the numbers to be the exact same thing, but you want the signs to be opposite so that when you add, it turns into a 0. The first thing that I normally look for is, can I multiply just a single equation to get these to match? And I don't think I can unless I'm going to multiply by a decimal, which I'd really like to avoid. And the second thing that I look at is, are any of the signs already opposite each other so I don't have to multiply by a negative number? And they are. My y's are. So I think what I'm going to do is I'm going to eliminate my y's. In order to do that, I'm going to have to do some multiplication. In order to get my y's to match, I have to figure out what both 4 and 5 can turn into. So you got to think bigger. So I know that 5 goes into 10, but 4 doesn't go into 10, so 10's not going to work. I can do 15 for 5, but that's not going to work for 4. I think 20 is the next one that's going to go in here. So I have to figure out what do I need to multiply the entire first equation by to get the y to be a 20y. And I believe that that is a positive 5. So I'm going to go ahead and take that, and I'm going to multiply this equation all the way through by a positive 5. So that's going to give me 15x plus 20y is equal to 30. All right, so now I have my first equation there now that I have adjusted that. All right, let's take a look at the next one. I need to turn the y into a 20. I still like the fact that it's negative. So in order to get that to happen, I'm going to times by 4. So if I go all the way through the equation, timesing by 4, that's going to give me 8x minus 20y, and that is going to give me 76, negative 76. All right, now if I take a look at my two equations, I believe I can add straight down and my y's will disappear. All right, so that gives me a 23x, and that is going to give me a negative 46. Okay, doesn't look spectacular. However, once we divide by 23, this actually goes in evenly. So those are going to cancel. I believe x is going to be negative 2. Now go back to the original equations, pick the one that you like the best. I think I'm going to choose the very first one only because the numbers are smaller. And I don't have to think about reorganizing it, I just need to make sure that I can plug stuff in where it belongs. So that's going to give me 3x plus 4y is equal to 6. All right, everywhere I see an x, I'm going to plug in a negative 2. And then go ahead and do the math, and let's see what we get here for y. So that gives me negative 6. I'm going to add 6 to the other side. So I'll get 4y is equal to 12. Divide by 4, and it looks like y is going to be equal to 3. Last thing I need to do is write my answer as a point. So my solution is alphabetic order x, comma, y.